So what are we going to do today? I'm going to go over the syllabus a bit and start data analysis. I divided data analysis into two parts, 1 and 2. I need to talk to you a bit about what you already know. Probably do both today or only one part, depending on what you guys know. So prerequisites. Let me start with syllabus. I will eventually give you the actual syllabus. I will upload it today on Blackboard, today evening, and you will go through it. But I decided to take the main features of it to let you know about them, all right? And probably listen to your feedback, and I want you to be aware of very important items. So the outline of this tiny presentation is to describe the lab, the course learning outcomes, when do we meet and where, the grading system and lab reports. Before I start, shall I assume that everybody took Physics 302? Or that's a wrong assumption?
No, I didn't take it.
No, I didn't take it.
All right.
I'm taking it right now.
Okay, so I can see. Can you tell me who took Physics 302? I just need
Me.
Okay, so we have Sherbil. Anyone else? So Sherbil, okay, so I can see in the chat that we have at least half the class who took Physics 302. Did you take it recently, like now in the fall? I suppose.
Yes.
Okay. All right. I was not the instructor, obviously.
It was Summer, Dr. Summer.
Okay. You need to know that Dr. Summer is a good friend of mine. Probably this will make you more confident while talking to me. It's like talking to Dr. Summer if you got used to her. All right. So listen up, which means half the class did not take any Physics 302. Is that true? So probably I should ask the opposite question. Who did not take Physics 302?
Doctor, sorry, do you mean the lab of...
yeah, the lab of classical
physics? But I took it. Sorry, I thought you meant...
Okay, so which means everybody did take a physics lab before, because I need to know how to approach data analysis. So you did previously data analysis. This is what I meant. So this session is going to be review for you, nothing new. All right, if you did not hear, all right, so Lean is the only student who did not take data analysis. I'm writing it down. All right, please confirm if I misunderstood. So Lean, and Lean is with us, I suppose. Lean, I'm gonna go normal speed. I'm gonna go a bit too fast for you. Let me know, stop me. A worst case scenario, we can meet after class during the week anytime you want if you believe you have gaps. All right, so I'm gonna...
Okay, thank you, doctor.
I'm gonna be your partner if you want throughout the semester. Quickly, description of the lab. Since you already did Physics 302, you basically remember that Physics 302 was mostly about mechanics, rotation involved, buoyancy. You did with simple harmonic motion, like waves and vibrations, and eventually you did some resonance in an air tube, and you eventually did heat, which is if some objects expanding, linear expansion, and specific heat. Now we're doing the other part of the physics. So we're gonna do electrostatic, electric field. This is also electrostatic. Then we have 1, 2, 3, where we have electric current, so electricity. So those are electricity related. This is the only experiment through magnetic field. So you'll end up doing electricity and magnetism. Then you do optics, isn't light wave and electromagnetic wave. So you can see the continuation. You will be offered 2 labs in optics, optics 1, optics 2. Eventually, we're doing modern physics, like modern stuff, interference and diffraction, and photoelectric effect. So electricity and magnetism, electrostatics, electricity and magnetism, optics, modern physics. Cool. Some of the students would find the electricity part a bit challenging. So please let me know if you have any problem anytime. Okay. Course learning outcome, they do exist in the syllabus. I want to remind you something. For the lab, the most important objective is teamwork and data analysis. I need to remind you that physics is not objective number 1, and that's why you have the course for it. Okay, so the course will teach you about physics, the lab will apply the physics you know, and you will learn some basic ideas basically, but data analysis is the main objective. So I don't want you to be frustrated when you see there's a lot of data analysis. Remember, this is the point of the course, which also means you have to fill in the gaps, because I'm sure you have gaps from last semester on the level of data analysis. So start filling your gaps and make sure you learn it very well. So you will be safe for this course. Okay, quickly, I know that the course is from 10 to 1. That's supposed to be PM, by the way. So we're meeting online every Saturday at 11. And if you have a problem, you will let me know. And you can see you are the only section in this course. It says 1 credit, around 3 hours. So I'm going to try my best to limit the online sessions below 90 minutes. I will try for us to give you more time through the lab report, okay? Also, I want you to have a quick look at the actual schedule. I just realized that it says April 3 holiday. Probably it's due to Easter break. I don't know. I've never looked at it. And you can see you have 5 experiments, then a midterm that we will have to decide the time and the date, the day actually. I think the midterm, we're going to cover the first 4 experiments, and the final exam, it's going to be the other ones. As you can see, it's the same as Physics 302, same approach, same repetition, and so on. It's only that the material cover is like you did the first part, and now you're doing the second part. Okay? So it's like you're doing the same lab, you're just simply continuing. All right, we're gonna use the same WebEx for any meeting we have during class or outside class. For office hours, you will see in the syllabus some office hours located in Zachem Engineering. And this is supposed to be when we go to campus, if we ever go. I thought, let's have office hours every single day you need me. Okay, you just have to inform me. I give you my free slots and we click on WebEx. Okay, so office hours are not 1 day a week. It's every time you need me. Please let me know. Now the grading system, it's gonna be very similar to Physics 302. You have the lab reports 50%, midterm and final exam 25-25. Cool? Now the lab reports, yes, you can work with one partner, and yes, it is optional. So yes, you can work alone. And if you ever work with a partner, you have to write the names of both students on the top of the lab report, and each student will have to present a copy, even if it's the same copy, just for me to keep track of who uploaded the work and who did not. Okay, I'm gonna show you how. Hopefully my method is similar to Miss Samar, but in case it's a bit different, it's basically only how to present your work and when. Okay, so this is how I usually show. Yeah, you want me to repeat which part? Okay, Yara, I was actually discussing a bit the grading system, and I'm gonna talk more about the lab reports in the next slides. You will be given a manual. I think I'm gonna give you the whole manual from day 1. I think it's silly to give you only per chapter, especially that the whole manual is 1 file. And you will have a piece of manual where you have the objective, the equipment, the theory, exactly like in Physics 302. And you have a lab report to fill in. So now you know that the lab report is basically a template to fill in, and you're not going to create your own, exactly like in Physics 302. Now for the names, I was saying that you can work with one partner, not more, and working with a partner is optional, which means if you want to work alone, and I believe it's better for you, do it. Okay, in case you pick a partner, please write both names under names. And let me show you this. Let me zoom in and move this to the side. You will have in the slot on Blackboard the experiment, which I believe is the video of the actual experiment. The lab report as a document. I'm gonna give you the whole manual, so I will not give you the lab report, it's the whole manual. Only save as the lab report part when you need to type your lab report. I will give you a doc and a PDF, so you use any app you want to type your lab report. I know docs are good for you, user-friendly. I know PDF is easier to read on your tablet or smartphone. A whiteboard or any presentation, a recorded session of the online sessions, and there's an icon called submit here. This is where you click and submit your lab report. Now, if you're working with a partner, keep a copy of the lab report for you, a copy with your partner, and each student will submit a copy. I'm not gonna correct twice, obviously. I will correct one and give you both the same grade. But it's good to submit both for me not to be confused. Otherwise, I would think that you skipped doing the lab report or you were delayed for a reason. Also, when you submit, I think it's a good idea to submit your document as PDF, because I had issues in the past where the students would submit a document and doc would look differently on Blackboard. So it may mess up your equations, it may mess up your graphs, your tables. So convert to PDF before you submit so I can see exactly what you see on your own screen. Also, make sure you submit one document. I had issues in the past, not with Physics 302, probably with my freshman students. They used to submit some random copy of some answers, some random tables, some random graphs, each in a different file. Remember, this is a lab report. It's an official document that you will have to submit later to your boss, to your customers, to your patient. So you're supposed to know how to write a reasonable lab report, an official one. I know you already been trained in 302 and Physics 302, but still it's good for me to tell you my expectations. I'm expecting a good looking lab report with the date, with the names. Please keep the tables neat. You can add and modify the tables, of course. What we give you is a template. Keep the questions clear. Don't answer only without showing what the question was. Use probably Times New Roman. Use font 12. All right. Insert your graph. Insert your drawings. Type your equations, and then convert everything PDF before you submit. All right. And if you need any technical help, please let me know, because eventually I'm here to help you and I'm not grading you for this. I'm just here to set some standards, okay? Every week فينا نغير partner. Of course, the partner is not supposed to be a constant, okay? You can work alone, Sherbel, or with one partner that you can change definitely, all right? I like teamwork. I only worry that you don't take part of the whole analysis and you will miss a very important part that you will not be aware of and you will be surprised in the midterm. This is my only worry. And please, no more than one partner, because otherwise it's going to be ridiculous. All right, so you will expect a video of the experiment. Now that you did Physics 302, you know what to expect. My videos are very similar to Dr. Samar's videos. Probably hers are better than mine. As you know, we don't have a team working with us, so the videos are homemade. I'm using my phone. My phone is not the great phone, It's not a great camera. Sometimes the sound is not clear. So let me know if the videos are not clear or anything, okay? So these are screenshots of random videos given for this course. Cool. I'm done with this part. Probably save. I don't know if we did any modification. And now let me start with data analysis 1. Since you know most of it, probably I will jump through the checklists and we move on if you're fine with it, okay? So the first part of any question before I continue related to the lab? Cool? I assume it's cool. All right. All right. Thank you so much. So this is the checklist I want to cover before moving to data analysis 2. So take a moment to think for yourself. Do you have any gap related to significant figures? And then measurements, averages, and RMS. Do you know how to use your calculator, how to do the calculations? Probably you've changed a calculator in the past. Probably you need help on that level. And then if you calculate a value, do you know how to do the propagation of error? I know you're supposed to know all this. I know probably you have some weaknesses here and there. So let's take today to make sure, or at least this week, to make sure we cover those skills and the extra skills in the next presentation before we start the actual experiments. Significant figures, quickly, I need someone, and by someone, let me have a quick look at your names. So this would help me on, this is the names. This would help.
Yalla, I can. One.
Thank you, Sharbel. Just give me a second. Sharbel, quickly, if can you discuss the rules here? Yeah. So
Yeah, بدك already money.
no, I want you simply to tell me which of those are considered significant figures, and let's do it fast. In between zeros, like zeros between non-zero digits, do you count
They
them?
they are considered significant figures.
Okay, and non-zero digits, do you count them?
أكيد.
Okay, leading zeros, do you count them?
Yes.
Never. Leading zeros are not counted through significant figures because I can simply replace them with times 10 to the power of negative something. So they are not here to give me information or to give me extra precision for the value. It's just an order of magnitude. So those, we never count them. Trailing zeros, Sharbel.
No.
We do count them when we have a decimal point. When we don't have a decimal point, we do not count them, okay? So in this case, I have a decimal point, I do count them. And you can see the rules in here. Okay, now, quickly, I can ask Yara. Yara, how many sig figs do you have in this one? Yes, Yara, speak up.
3.
Okay, and the next one, Yara?
3 as well.
3 as well. The next one?
2 because there's no decimal number. Sorry. No, there's no decimal
There
point
is a
after the
decimal.
zero.
Look, you already have a decimal here. So this 0 is counted. Why?
Okay.
Because
I
we
thought
put
after
it. No. So basically, we were gonna count all these. The 0 is important because it tells me that the value, the measurement, is more precise than the one without the 0. Okay, so to give me more information about precision. What about this one, Yara?
2.
2. Thank you, Yara. Probably talk to Maria. Maria, how many sig fig for this one?
Only 1.
Only 1. Next.
4.
Next.
3.
1. Only 1. Because this can be written as 5 times 10 to the 2. All right. So when I say $500, I'm not sure about the precision. It's like between 600 and 400. I know dollars are a lot, and saying that the range is between 400 to 600 would make you feel that you're freaking out. But just imagine we're talking about something so random, like 500 second. No, yeah, probably, So 500 means no precision at all. Otherwise, I'm going to say 500.0, like in this case. Maria, in this case, how many sig figs do you have?
4.
Exactly.
Because there's a decimal.
Exactly. So every time you don't have a decimal, do not count the trailing zeros, because I can write 5 times 10 to the 2. All right, so this is the rule in case you need a reminder. Now, this is something I want you to try on your own and probably give you a week to do it, okay? So how about I take a screenshot of this one and send it to you. If you want, you can also take a screenshot yourself, because I will upload those in the evening. Probably you want to do them now before lunch. All right, I'm ready to start measurements. I would want to ask quickly Karen. Karen, I'm sure you used some measuring tools this morning, right?
Yes.
What measuring tools did you use? Any measuring tool? A homemade? A cup? Did you say cup?
Yes.
I love it.
Yes.
You used the cup. What else?
That's it.
Okay. All right. Probably I can ask Anna, and everybody else in the chat you can answer. So Anna, did you use any measuring tool this morning?
Can we say a spoon?
A spoon? Of course, a spoon is a measuring tool. Anything else?
It's also a cup, so I don't know.
Okay, anything to measure like numbers? Come on.
Yes, me.
Yes, Sherbel.
I used the calculator أعمل لك ال $500 على الريت اليوم.
Okay.
هلا بقى.
Is the calculator a measuring tool?
It's a شو كنا نقول له؟
It has a screen, yes, but it doesn't measure. Can I measure anything with it? No, I don't think so, unless you can prove me wrong. I don't know. A calculator is not a measuring tool according to me. Anybody did use a measuring tool other than a cup and a spoon? This
A
is
bowl.
a bowl. All right. Anything else? A weight scale, a ruler. Thank you so much. So I'm gonna say a bathroom scale. Obviously, you know, Saturday morning, you wanna see what the lockdown did to you. A ruler, you can do some measurements. Why not? Anything else? I used the thermometer. I used my car this morning, so I looked at the temperature. Anything else? Stopwatch. My kids were playing on the iPad and I timed them 30 minutes. What else? All right. Thank you so much. Now we're going to try to divide those measuring tools into digital and analog. All right. So a digital measuring tool and an analog measuring tool, because you know, when I need to deal with uncertainties, I need to know if my measuring tool is digital or not. All right. How do we define a digital measuring tool? Like, for example, if I use those, which one of those could be digital?
Thermometer.
The thermometer could be digital, yes. Let me underline. The stopwatch could be. And you know, the thermometer doesn't have to be. I can see in the chat that the bathroom scale could be digital. Okay? Yeah, the ruler is digital or analog?
It's the analog.
Exactly. Cup and spoon?
Analog.
All right. So now we can say that digital is something that has a screen. It gives you numbers. Analog is something that is very similar to a ruler, or it has a needle, but you can read on some graduations. The way we approach uncertainty is actually different. Let me show you a bit some rules. It's written somewhere else here. So every time you have a digital measuring tool, the uncertainty is the smallest subdivision only. A smallest subdivision means the smallest measurement. And we're going to take an example. And for an analog measuring tool, the uncertainty is the smallest subdivision divided by 2. So divided by 2 is only for the analog. For the digital, you don't divide by 2. Okay? Because the digital, you don't do any estimation. However, in the analog, you have to estimate half the smallest subdivision. Let me go back to this measurement. This measurement, and probably I'm bothered by my small screen, or small is a perspective probably. Okay, because I want to use my whole screen and see the chats and see your faces. All right, I'm gonna take the first measurement to be analog, and I want to ask Guy. Guy, I want us please to do the measurement of the red line you can see on the screen. Yes? So I'm gonna say L equals. Is Guy available? Probably Janti can take over.
Yes.
Okay, Janti. Yes.
2.3
unit.
plus minus 0.1 over 2.
0.1 over 2. Okay, I'm so confused. I need to know units, because probably you mean millimeters or probably centimeters. If you don't tell me, it's so random.
Centimeters.
Okay, for both?
For L, centimeters. Centimeters, and we can convert it to millimeters. بس مش لازم يكون same unit.
All right.
يعني
So yes, let's use the same unit for both, for the measurement and the uncertainty. And we can use millimeter, you can use centimeters, anything you want, but say something so we can communicate better. Thank you, Shabel, for informing me about Guy. All right, now we need to follow some rules. The rules are, and stay with me, Genti. The rules are uncertainties must follow 3 steps, 3 rules. 1, they should be 1 sig fig. 2, you should have a unit. 3, the measurement and the uncertainty should have the same precision, meaning the same number of decimals. Let's go back to our measurements. 1 sig fig, yes. Unit, yes. Now precision. Uncertainty and the measurement should have the same number of decimals. Can we fix the measurement now?
2.30. We should add a 0.
30 is good. You can say 31. You can say 32. It doesn't matter because you're still within the margin of error. Okay, so if your partner would say 32 or 35 or 31, you're not supposed to fight because all the answers are acceptable. And since I have the right to estimate the last digit, let me put the last digit in bold and underline. That's why we have the uncertainty on a decimal number 2. Which means the 3 I'm very sure about, probably mark it in red, to say the 3 cannot be a 4, cannot be a 2. I'm very sure about it. And by adding a 0, it's only to insist on saying that the 3 is very sure, okay? If you don't add a 0, it's as if you're telling whoever is reading your lab report that 3 is an estimation. And since 3 is not an estimation, add a digit to reinforce that 3 is very well there. Okay, so this is how we deal with an example of an analog measuring tool. I know you already did that before. Probably this is a quick review for you. Now, measurement number 2, I'm gonna ask Roy to help me, and I'm gonna do a digital measuring tool. Okay, so digital measuring tool. Green is not visible at all. Let me go back to black. I mean to white or anything. All right, so Roy, let's talk about my neighbor. My neighbor did the measurement for his own mass, and he got M equals 65.8 kilograms. All right, this is a digital measuring tool. Can you please help me write the uncertainty?
Would be equal to plus or minus 0.1 kg.
All right, simply because it's the smallest measurement, right?
Yes.
Okay, so since you can see, this is all you can see on the screen, you can tell that the smallest measurement is this. You cannot go smaller, and it's wrong to go higher. So I think you got the idea behind measurement. This is a quick reminder that we are actually discussing the instrumental error. And I wanted to show you 2 rulers having different uncertainties. You have feet, you have inches here, centimeters. And even if you have inches here and there, just a second, here and there, you can see it's the same, but the smallest subdivision here is different. So this measuring tool is more precise. This measuring tool is less precise. So you have different types of rulers all over the bookstores. So each ruler will have a different precision. Your case, the ruler that you basically have at home is very similar to this one. Okay, and I do understand when you say 0.1 centimeters divided by 2. Do you think you are ready to do this on your own? Let me give you a screenshot. And before moving on, I would like to ask Abdo if he's with me. Abdo, quick questions. I just want to know if this is digital or analog. Is Abdo there?
Hi, Doc.
Hello, Abdo. All right, so is that digital or analog?
This is analog. We're balanced with digital.
وهيدا
وهيدي كمان
Say it again.
Liquid and glass thermometer.
Analog. All right, awesome. And don't forget, every time you have the uncertainties, you follow the rules. By the way, here you are asked to do the measurement with the uncertainty, okay? And please do follow the rules. All right, now we're ready to do averages. If I go back to my checklist, we're done with this, doing averages. I suppose you know how to do it. So let me start directly asking Lean. By the way, Lean, Probably I was going fast.
Yes, doctor.
I'm expecting you to ask me or to write down your questions. We have to meet later if needed, okay? Lean, I want you to find the average of those masses. So those are different trials done by the same person at the same time in the same conditions. We call them trial 1, 2, 3. It's only to make sure the measurement is good. I'm not sure this will increase accuracy because probably the bathroom scale is not functioning well, but I'm sure this will increase the precision a bit because we're doing only 3 measurements. So Lean, how do you find the average of those and how do you do it?
We add the 3 measurements and then we divide them by 3.
Okay, the answer is, somebody said 89.3. Karine, do you agree, Lean? Can you do it quickly?
Yes, I'm doing it.
Okay, Karine, what's the answer? What's the unit? Okay, always answer with the unit, okay? I know Physics 302 was not enough to change the way you perceive numbers because you've been perceiving numbers since the day you were born as mathematical values. And it's only until recently you see...
Doctor, it is 89.3.
Okay, great. So what Lean and Karen did and Yara confirmed, they actually did X bar, which is usually the average, is equal to sigma xi summing over n. N is the number of trials. So let me call this M bar, okay, or M average. Now, how do you find the error on the average? Anybody, probably Maria, can discuss that with me?
I can help you if you want.
Okay, if Maria would need help, please, Sharbil, I want you to interfere. Yes, Maria, how do you find the error on the average? What do you remember from the previous course?
I took the Physics 302 last year, so I kind of forgot a little bit.
All right, so Guy just told us we do standard deviation divided by square root of n, and that's true. Let me call the standard deviation probably like this, divided by radical n. Maria, do you remember if you used to do it on the calculator or by hand?
I think by calculator.
Okay. Yes, Sharbel. The floor is yours.
نحن تعلمناها على اكسل يعني equals average equal STDV والerror equal STDV over square root of n.
Okay, what do you mean by Excel? Like Excel will do the standard deviation for you?
Yes.
Oh, awesome! I love the Excel. Why not? Do you know how to do it on a regular Casio?
If you want, بس إنه لعبك بتصير للصراحة.
Okay, I'm happy to see how. I'm happy if you guys are using Excel. I'm happy if you guys are using a calculator. Just learn a method, and both methods are can be used in a final exam. Okay, so any method that would work is good. For me, I would say do not use this equation. It's time consuming. Learn how to do the work on Excel. Or learn how to do it on a calculator. If you go to this YouTube link, I showed the students using my own calculator how to do it, okay? So for the newcomers or for the students who need a method, probably I can make another video to show you how to do it on Excel, because probably you need a reminder, okay? So the YouTube link will teach you how to do it on a regular Casio. Also, if your calculator is a bit different than mine, let me know. I can show you how to do it on yours. But whatever you do, you have to know a method, and the method is personal. I mean, each student will have her own method, his own method, on his own calculator. You see, what works on your calculator may not work on your friend's calculator. All right, so Yara just said, please on Excel as I have a different calculator. Yes, Yara, even if you have a different calculator, I can also teach you. So basically, I think Excel or calculator will take the same time. Probably Excel is easier because your laptop is more user-friendly than this calculator, you know? But basically here, you plug in the values in a table, click, it gives you the standard deviation. So same, okay? So yes, I need to make an Excel video for you. Unless somebody would want to do it for us, let me know. Okay, we can share it to the class. So can I assume, all right, so far I assume Lynn did not get it, unless Lynn will go over the YouTube video to learn. So Lynn, you have a gap in here, and the gap is, if you want to take note, how to find the error on an average. Question mark for Lynn. Okay?
Okay, I'm gonna watch the YouTube video, doctor.
Okay, make sure you understand. If you don't, please do not delay this gap more than a week. So let's cover it, okay?
Doctor, don't worry. أنا لين مساعدة.
Come in.
She's my cousin.
Okay, thank you for that. In case you need help, let me know. Since you guys know how to do averages and RMS, I want you to try this. You are given the temperature of a child, 6 different trials. I know these are very easy examples, just a quick reminder, you know, simple applications, I call them. So you try this on your own and you find the average and the RMS. I'm gonna take a screenshot and send you all the screenshots. So you have tiny assignments for next week. These assignments are not optional. I want everybody to try. And since they're easy, why not? And no, they're not graded. So not optional and not graded. All right, now we're gonna do some calculations. Let me go back to this to show you we're done with this and we're doing now this. Okay, calculated values. Okay. This F equals MA. Somebody did the measurement for A. I can see a measurement. I can see an uncertainty. I can see following 3 rules. Uncertainty is 1 sig fig. I can see a unit. I can see the rounding is perfect. Same number of decimals. Somebody did that. Digital measuring tool, analog measuring tool. I have no idea. Same for the mass. They did the measurements. Probably your partner, my neighbor, anybody. My job is to calculate F and the error on F. Calculate, not measure. With this given. Okay? Nagam, find F for me, please. And let's do it quickly. Yes, Nagam, I'm all ears. If Nagam is not here, probably Muhammad can help me. I hear you, Sherbel. Muhammad not here. Hussein?
Yes, hello.
Hello. Can you help me find F, please?
Yes, we just multiply them and then we have to get the error of the calculation.
Okay, do you have anything to do with the calculation with me? So we're gonna do 2.2 times 15.8.
34.67 Newton.
Yes.
Can you say it again in English? So it's 34.76.
0.76.
Okay.
Newton.
All right. So far, I don't care about the rounding. I'm gonna round later. Okay. Thank you, Hussein. Now to find the error on F, we need to understand that the error of M will propagate through F, and the error on A will propagate through F. And who would actually dictate the propagation at the function that is multiplication? So that's why we're gonna do propagation of error. Okay, I know that Sherbel just said we do some derivatives. I know you have methods from chemistry lab, and yes, you can use them, and yes, they will give you the same answer. I know the method you know from chemistry lab would give you multiplication, division, plus and minus. I know you need a general method in case you have sine, cosine, square root, I don't know, some inverse exponential function, whatever. So let me deal with the error on F, on a calculated value. I know that the propagation of error is actually an ugly equation. I don't want you to freak out. Let's try to translate it into English. Yes.
كنا بتذكر انه it's radical of شيء خاصه بF minus هي خاص.
All right. So I know this equation looks horrible, and I want you to know that since this is not a math course, I don't want you to freak out. I can do the work for you. Okay, I just want to translate those into the following. This is, if you want to write it in English, this is the derivative of f. F is a function. Let me remind you, f is m times a. By the way, what is this law? It's a very famous law. Have you ever heard of it?
Second law of Newton.
Yeah, Newton is my favorite. All right, so this is the derivative of f. This is another derivative of f. And this is another derivative of f. The difference between those derivatives is that you see I have two parameters, two variables in here. Every time I take one to be my x. Yes, we call them partial derivative, of course, but I don't wanna use like those mathematical terms because I know some of you would freak out. You hate that, I know. So I'm gonna simply call them derivative, but you take each variable to be your x by turn. So initially I'm gonna take m to be my x, and this is my constant. Next, I'm gonna take a to be my x and m to be a constant. Okay, and do the derivative. Cool. I only have two parameters, so I don't have a third one. So I'm gonna do the derivative of a with respect to a, derivative of f with respect to a, derivative of f with respect to m. I'm gonna say derivative of f if a is a variable, derivative of f if m is a variable. Okay, and probably I'm gonna ask Aya here to help me. Aya, I'm gonna write the function where a is my x. So it's gonna be equal to mx. Another function, I'm gonna write it where m is my x. So it's gonna be a, let me change it into x times a, just to keep the order. So this is f equals ma. I took a to be x, then I took m to be x. But before we continue, Aya, can you please remind me the following? If I have a constant, what is the derivative of a constant, Aya? Probably Aya is signing in and out and she has difficulties to hear me. Okay, I want to ask Anna.
Yes, doctor.
Okay, Anna, what is the derivative of c if c is a constant?
0.
All right, if I have cx, what's the derivative?
C.
Okay, if I have c x to the power 3,
It would be 2c. Sorry, 2c. To the power 3, you said?
yes.
3c then.
So it's gonna be 3c. What about the x?
X squared.
Exactly, x to the power 3 minus 2. So it's minus 1, I mean, it's gonna be x squared. So if I have x to the power n, I say n, x to the power n minus 1. Then what happens if you have c over x? This color is so bright to my eyes, I hate it. Yes, c over x, what's the derivative?
Isn't it something 1 over x squared times
Exactly,
c
so
or something?
it's c over x squared with a negative sign. Okay, I'm glad you remember. And again, this course is not a math course. You don't know, you ask me. You don't know how to do it, Jessie does it for you, okay? You just need to ask and to write it down somewhere so you can use it. Now, probably I can ask Jad to help me if Jad is still there, because I can see Jad was signing in and out. If Jad is not available, probably Iman can help me. Iman? Not here. How about Abdo?
دكتور قولي لي.
Okay, so Abdo, I want you to do the derivative of this.
تبع mx.
Yes, obviously x is the variable.
اوكي. هي المفروض تبقى عندنا بس الام.
Exactly, so it's m. Now let me change the pen, it's killing my eyes. Let's do derivative of this one. This is worse. Yes, this one.
اوكي هون بضل عندنا بس ال
A. All right. I suppose you have a calculator. Hot m times error on a times error on m, square each plus radical, and let me show you the values here. Okay. So can you give me an answer?
معي كالكوليتر.
ليش؟ مين بيجي على فيزيكس لاب بلا كالكوليتر؟
دكتور قال انه بالفاينل تبع هيداك اللاب انفقت الكالكوليتر تبعي وبعد ما اشتريت وحده وهلا كله مسكر بقى ناطر فيفتحه.
شو
اصلا
صار؟
كثير غالي حقها 150,000.
هيدي الكاسيو. Really?
ايه عادي $20 حقها 150,000.
طب do you need it?
لا انا اصلا كل شيء دكتور عبده معه كثير مصاري ما تعتل.
طب عبده just tell me again what happened to your calculator?
وقعت دكتور صارت نص الشاشة رقم النص الثاني من تحت ما بيبين. فعم بستعمل كل شيء على اكسل.
And why not? So we can do this on Excel, I suppose. All right, so this is like a reason why to try our best to use the calculator less and the Excel more, I don't know. So probably Karen can give me an answer, a quick answer for the error on F. I'm gonna write it here, error on F. By the way, everybody can help us with the error on F. Just do the calculations, show your answer in the chat, and we can easily do the rounding together. So we're gonna do M, which is this, times the error on A, which is this. Then we're gonna do A, which is this, times the error on A, which is this. So, any answer? I'm gonna be quiet for a minute, 1 minute. All right, someone said 1.8. Let's wait for more answers. All right, thank you, Guy, for rounding it to 1 sig fig. It has to be 1 sig fig. All uncertainties should be 1 sig fig because they tell me which digit is fluctuating, which means it doesn't make sense to give 2 sig figs because if you have 2 fluctuating digits, the second digit is not needed because it doesn't make sense. All right. So far, everybody is giving 1.8 or 2. Anyone with a unit? So 1 sig fig, unit, and the third step, we can do it together later. Newtons, okay. So we're gonna say, let me go back to the previous slide. The error on F is actually 2 newtons. Then I need help rounding my actual value, this one. How can I round it? All right, since this one has no decimals at all, F is, should be written as 35 and then plus or minus the uncertainty that is 2 and all that is to the power n, I mean to the unit n, and this is my force, okay? 4 times 10 to the 2, what do you mean, Yara? Can you please speak up? 4 times 10 to the 2 is 400. Why did you type this? What answer is this? 4 times 10. You wanted to round your force to 1 sig fig. No need, no need. Please do not do that. No. Only the uncertainty we round to 1 sig fig. Then we add a unit. Then we make sure that F and alpha F have the same number of decimals, not sig fig. Otherwise, all your measurements will be 1 sig fig, and that's horrible. Horrible because it's a very little, tiny piece of information. All right? Cool. So this is the answer, Yara. Let's use it. Yes, Roy.
Sorry for the interruption. I've got a question concerning rounding. What if the first decimal place was 5, like 34.5? Do we always round up, or do we like round like we used to do in 302? We check the value that is before, if it's odd or even, and then we round up or down.
All right, listen. You need to understand that 5 is in the middle, and you need to understand that statistical methods are basically there to help us, okay? You can do whatever you want, and I know for a fact this example will not come throughout the semester, so why worry? But if you want to know the international way to do it, because we're here to learn a language that is international, we should follow the even odd rule. All right, which means 34.5 will be written as 34. However, 35.5 will be written as 36. This is what you use in Physics 302.
302 yes. 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 302 yes.
All right, so this is the international method to follow. But let's say you end up saying in a different way, it's okay. You know, those are statistical methods just to be able to communicate in a good way. So since 5 is in the middle, they wanted to create a law that is 50% round up, 50%, just to make it statistically acceptable, you know? All right, so now do you think you can do this on your own? Obviously, the question is to find R with the uncertainty on it. And as you can see, this is Ohm's law, which is a law that we can use in electricity. You are given U with the error on it. You are given I with the error on it. Be careful, you have milliamperes. So obviously you need to convert to amperes. All right, let me take a screenshot of this one and throw it on your blackboard. So this is also a tiny assignment. Please try to use the assignment to warm up a bit on your Excel, because I know that since you want to use Excel, it will be a good opportunity to set everything ready for the course. All right, so now let me see presentation number 2, and if we're gonna do it today or not. Probably we can go over it quickly. It will be a good idea to finish from it. However, I don't want to overwhelm Lean, so probably go quickly over this and discuss it next time again quickly as well. All right, so for the students who already have reasonable graph skills, you don't need to worry about the whole thing. So the content was actually a graph. Why is it a good communication? It is actually a good communication tool, so use it as such. You need to communicate something. It has to have some items, otherwise it's not a good communication tool. Why do we care about linear relationships? How do we calculate the slope? Why do we need the slope? And what's the error on the slope? How do we find it? You know all this, I suppose. So I was discussing the fact that for us to have a nice, clear communication tool, we need a minimum of a title. Aya, please mute yourself. Is that possible? Do you think I can mute Aya? Probably she cannot hear me. I cannot mute her, I think. All right, anyway, no big deal. It's very minor. All right, so the thing is, it's important to show a title, label your axis, add units, have a legend, use colors probably. Remember, and most of you are not putting any title. If you don't label your axis, it means your graph is not a good communication tool, which means you don't need it, don't use it, it doesn't make sense, delete it, you see? This is an example where you have, I don't know, a legend. You can see the title, but I'm not gonna take my time on this because you already know this. This is a presentation for students who never did this before. This is also, as you can see, a graph, but probably the labeling of the axis was not well done. You don't see any units, you don't understand what it is, there's no title. All right, so some of these graphs are missing something. All right, have a look and think about what is it missing. This is also a graph that shows some legend. The title means nothing. The labeling is not existent, no units, although it looks nice, but how can I read it? All right, this is also another graph that is lacking a lot of information. Now, linear relationships. I just showed that this could be linear, and not. All right, and then I showed here that if you ever plot T versus L, T is the period of a simple pendulum and L is the length of the simple pendulum, you will not get a linear relationship. But however, you can make it linear if you ever plot T squared versus L. By the way, for me to be clear a bit, let me remind you that T is equal for a simple pendulum 2 pi radical L over G, where L is the length of the pendulum as G is the gravitational field strength. You see that T and radical L are proportional, or T squared versus L can also be showing a linear relationship. Okay, that's why plotting T squared versus L will give you a straight line. Here I want to remind you about the equation, and let me move the chats a bit. The equation of the function, it's the equation of a straight line not really passing through the origin. If you zoom in, it's not hitting 0. You see the slope is given and the y-intercept is given by Excel. And everybody should learn how to plot on Excel, how to do the trend line, and how to show the equation of the straight line. If you cannot, I can definitely help you. Also, you can look at R squared. R squared is the coefficient that would show you how close you are to a straight line. You see a certain scattering. The scattering here is very visible. And this scattering means that probably the values you have are proportional, and the scattering could be due to many errors you have in the experiment. Okay, so for you to be able to assess how far away or how big the scattering is, R squared can help you. R squared is equal to 1 whenever you have a super mathematical linear curve graph plot. 0.99 means this is great, you know, very close to a linear relationship. This could give you probably 0.8 or 0.7. I don't have a unit or a scale to tell how big the scattering is, but R squared basically will tell me a lot about linear or not. You can see a title, by the way, label with unit, and that's awesome. All right, here they show you a linear graph. You see title, label with unit, label with unit. You see the points, you see the equation of the straight line. All right. This is the slope, this is the y-intercept. In this case, you are given different R's. You see 0.98, 0.96, 0.855. This is not great. It's zoomed in, so I cannot see the other points. This is 0.99. This is only to show you that R could be a very important thing to keep in mind. So always write the equation with the R squared value. Don't do the mistake of some students who would have a graph that is not linear and they do the linear regression for it. Come on, look at R. It's not even close to 0.9. I always had students doing projectile motion. By the way, your first experiment is projectile motion, plotting y versus x, and you're supposed to get the parabola. And for some reason, they do linear regression, and this doesn't make sense at all. It's not supposed to be linear. Why do the linear regression? Okay, so be careful. Not any function is linear. All right, now how do you find the slope? Calculate the slope. Please do not do this unless you are given the line and you have the points on the line. In most of the experiments given to you, you have the points only, and none of the points is on the line. So do not do this equation, please. What you should do is, you either use Excel and you do the scatter. So you plug in you put your values in a table, you select, you insert the scatter, and then right-click, add trend line, show equation. I suppose everybody knows how to do this except Lean. Okay, so Lean, please add on your checklist the things you need to learn. And we will have a session where I can teach you all this. And or you can use Excel again. This is a continuation of the previous slide to show you that you can add the equation and the R squared value.
Doctor, I did them in the French baccalaureate in the TEPES we used to do.
Okay, awesome. So hopefully you know most of them. Again, I'm here to go over it all with you. Just let me know, okay? Great, you know most of it. Yes, nowadays in high school, most of the students know a lot of these. All right, so this is A using Excel, and this is what you guys are gonna do. Some students though know how to use it on a calculator. In the past, we used to use the calculator because your final exam was done on campus. And you know, on campus, you have a calculator, and usually physics lab is not computer-based, so you don't have Excel. But now on campus or not on campus, it's gonna be computer-based. You can trust me on that. So which means you can use Excel all the way. How about you don't learn how to do it on the calculator? Why learn something you're not gonna use? All right. Usually I give the students two methods. I know that you need Excel because you need to plug it in your lab report and not use a calculator. Why not? Okay, so it's up to you actually. You can still watch the video. I'm gonna send you the link. Probably throw all the videos on Blackboard. Now you're supposed to try this on your own. I just erased the answer, okay, because I thought probably keep the answer to compare later on. The problem is use Excel and do not use the calculator to deduce the resistance of your circuit. You are given I, you are given U, you are given the function, Ohm's law, and the question is use Excel to deduce R. Be careful, R could be the slope or not. I'm gonna take a screenshot of this one so you can have all the assignments together in one folder. All right, item 4, I know I'm going fast on this one, but I'm gonna go over it again next time I see you. So we're done with 1, 2, 3. Now item 4, what is the slope needed for? Which
To
means,
calculate the error on the slope.
yes, we can do that, but like in here, we need the slope to find R.
Yes, also.
Yeah, so we find the slope because the slope represents a very important constant in my system. It could be R, it could be 1 over R, it could be related to R or mass or something. Slope is very important. Like in here, we did something, we plot T squared versus L because the slope represents something obviously related to G, and G is a constant because you are in a position where G is constant. All right, so no, the error on the slope is not my purpose. Here you are given many examples. All right, so probably Sherbel can help me. Sherbel, if I plot F versus A, what do you think the slope will give me? Obviously it's linear, no? Do you agree?
Yes, doctor, can you repeat the question? And it was lagging.
All right,
Please.
so I'm gonna plot F versus A. And obviously, I see it's proportional, so the plot is gonna be linear. The question is, the slope here, what does it represent?
Okay, so the slope is يعني مثل ما أنا بفكر فيها it will represent M.
Okay, because we do y is equal to slope times x, and I can see that x is my acceleration and the force is my y-axis. So obviously this is the slope, which is m, because I have f equals ma.
Yes.
Okay, back to you, Sherbel. If I ever plot a versus f, what will be the slope? What will it represent?
A versus F, 1 over M.
Yes, just be careful about that. And here, if I ever plot u versus I, what would be the slope?
R.
Okay, if I plot R versus I, sometimes I vary the resistance and I measure the I. Do you think I get a linear relationship?
I think no.
It's gonna be a hyperbola because R is u over I, so constant over x, and it's gonna be a hyperbola. So you cannot do linear regression, and the slope represents something that is a variable. All right? You're laughing because?
Yes, because شكلها غريب عجيب مش شايفينها في حياتنا بولا لعب هيدي.
I know. In the physics labs, we look for linear relationships.
Yes.
And you need to know that nature is not linear. Not always. We make it linear. Like here, we make it linear for research purposes. If we plot T versus L, do you think it's gonna be linear?
I don't think so.
It's gonna be like this.
Doctor, can I tell you something?
Of course.
Last semester when كنا نعمل يعني الجراف مرات كان يطلع لنا هيك اشياء نرجع نضل نظبطها تصير بالعكس تصير لينير يعني نقعد نغير يعني بالواي والاكس كرمال عرفتي كيف شقلبهم كذا مره ترجع تزبط.
Okay, I like this. I know it's called cheating, but it's trying to understand what's happening to your system. Somebody was giving you the measurements, right?
Yes, but it's not called cheating. I think يعني
But you were changing the
مرات كنا
measurements.
نجبر نعملها هيك.
Okay,
عرفتي
but
كيف؟
okay, but tell me something. You were changing the measurements, right?
لا بس يعني نغير الفاريشنز نحط مطرح تي مثلا قال ومطرح قال نحط التي عرفتي كيف؟
I see what you mean. So you used to pick your x and y. If you don't like it, pick again. And this is called trial and error. And no, this is not cheating. This is only trying to understand how the system is working. All right. And if you, usually when you don't know, you don't understand the physics behind your problem, sometimes, and most researchers do that, they don't know the theorem. They're actually here to analyze the system and to understand how it functions. They do exactly what you were actually doing, trial and error. Here, since we know the theory and the theory comes before the experiment, unlike research itself, you can use the theory to understand the system and then analyze your experiment itself. So for example, here you know the equation, right? And you know, obviously, if you plot T versus radical L, you will get it in your relationship. Do you think it's gonna work? T versus radical L. Do you think it's gonna be linear? No?
I don't think.
Okay, let me insert a new slide, and let me use it. Okay. Okay, let me remove those. They bother me. Okay, so let me do that with you. We have T to be equal to 2 pi radical L over G. I'm gonna write it as radical L alone and radical G alone. Okay, I'm gonna take this to be my Y. So it's gonna be Y equals, I'm gonna take this to be my X equals, and let me think about this one. Is it a constant? 2 is constant, pi is constant, radical G is constant. I'm gonna take G to be 9.81 meter per second squared, if you want. Okay, meter per second squared. Okay, so it is a constant. So I'm gonna say Y is equal to AX. This is a straight line passing through the origin, taking T to be my Y-axis and radical L to be my X-axis. So if I ever plot T versus radical L, yes, I get a straight line passing through the origin. However, if I plot T versus L, I get Y is equal to a constant times radical X, which is not a straight line passing through the origin. I can also write T squared to be equal to 4 pi squared. By the way, pi squared is very close to 10, G times L, right? Do you agree that this equation is exactly the same?
Yes.
So if you plot T squared versus L, do you get a linear relationship?
Yep.
So this is my Y, this is my X, and the remaining is a constant. So yes, it's gonna be Y equals AX, so straight line passing through the origin. So study your function. Any function can be made linear. Let me give you another example, and let me be a bit smarter, insert a slide that is empty. Do I have this option? Probably this one. All right, so I'm gonna show you an example. I forgot which example. Okay, acceleration on an incline is equal to, all right, let me remove this, it's horrible. Okay, I shouldn't do this, waste my time. All right, so the acceleration for an incline is G sine theta, right? Can you tell me what to plot to get a linear relationship? Try, Sherbel. There's always a way to make my functions look linear. I can force them into a linear relationship. By the way, any student doing research will have to do this because linear relationships are easier to analyze. It's very nice if you can find constants in your problems, and they always exist. So what do you plot, Sherbel?
A en fonction de sinus theta.
Okay, so you plot A versus sine theta, and it's gonna be this your Y, this your X. So what's the slope?
G.
Constant. Well done. Perfect. So you got the idea. So there's always a way. Where were we? There's always a way to make our functions linear. Some functions are not. And every time you do a linear relationship, a linear function, you need to know what the slope represents. Okay? Now error on the slope quickly. You can see those points not well scattered around the line. And you can see a lot of scattering here. So the error on the slope is related to how far or how big the scattering is. And here they show you a lot of scattering, a small scattering. You see this vertical deviation, this is what we care about. We need to find the vertical deviation. So we're gonna take the y of the point and the
minus yi.
Exactly, y of this the line, and do the difference to do the deviation, and then square it, and then add all the deviation squared, exactly like you do in RMS. This shows you how to find the error on the slope using the equation. Where's the equation? All right. This shows you the vertical deviation. All right, the equation is given in the video. I need some feedback from you. How do you find the error on the slope? How did you do it previously?
بنعمل y minus yi بنرجع بنعملها سكوير بنرجع بنعمل دلتا بنرجع بنعمل n times.
Okay, wait a bit. Let me show you the equation to see if we're talking about the same thing. Probably go to the actual document. By the way, this is what I'm willing to give you, our manual. By the way, chapter number 1 is Introduction to Error Analysis. Go over it. Lean, this is very important for you and everyone else. So Sherbil is discussing the following equation. It will be nice if we can take a screenshot of it and put it on the slides. Okay, but eventually all this presentation will be visited again next week. Okay, so let me insert the screenshot here and let me discuss each term along with Sherbil. Just a second for it to show. Okay. So basically Sherbil is discussing EI. EI is the deviation. Okay, so EI, E1 is basically Y1, the ordinate of the point, minus Y of the equation. Let me call it bx plus a, bx1 plus a, okay, plus a. All right, so this is the equation or the straight line, and this is the point. This is called a vertical deviation. I need to square each and add them up. Delta is something else that is given by the manual here. This is delta. So delta is, yes, you need to add all the x's together, square the sum, and here square each x, add them again. And you can definitely do this one on an Excel spreadsheet. You have all the x, you have all the y, you square each x and click sum, or you can do the sum and square the final answer multiplied by n is the number of points. So done with delta. And what is n? Basically we just said it's the number of points, so you do n over n minus 2. It's very important to remember that all this is the error squared, and what I mean by error squared, you're supposed to eventually do the radical to get the answer and follow the 3 steps. Round to 1 sig fig, add a unit, and make sure your slope and the error on the slope follow the same precision or the same number of decimals. All right, for the students who already were doing this last semester, probably you know what I'm talking about. However, I want us to go over this again next time I see you. This is something for you to try on your own. This was already done in this slide. So it's the same exact thing, but now the question is find the error. Okay, so I didn't want you to repeat some other problem. It's the same problem. The first slide was find the slope. The second slide was find the error on the slope. Next time I see you, I'm gonna go over all the assignments. And yes, you can do everything on Excel if you want. It's up to you. And therefore, I'm gonna give you a week to make sure you cover all this again, to fill in your gaps. Please get back to me if you have questions. We have a week. We can meet every single day, anytime you want. And next time I see you, I will go over the whole presentation again to make sure you're done with it. Okay, let me save it with the notes on. Please let me know if you cannot see the annotations, because I heard from some other students that sometimes the annotations are not visible. If they're not visible, I can convert to PDF and send it again. All right, now let me answer all your questions in the chat. Should we submit the assignments? Yes, please submit the assignments. they're not gonna be graded, but it's not optional. I want you to submit it, okay? Do the work. It's really simple. We're talking about simple application. Probably you can do it today or in the evening. It should take you around 30 minutes. When will I upload them? In the evening, Roy. However, if you cannot wait, let me know, okay? Probably I can send them on WhatsApp unofficially for you to start. In which form and when is the deadline? So I think a week, meaning Friday evening, if you can do it by Friday evening. In which form you will have to go, let me show you again. Okay, let me show you a sample. If you go to Blackboard, let me show you any course I have, not yours because I did not put it on yours yet. Let me say this is your Blackboard. You will see something like item 0 data analysis. You click on it, you will see the PowerPoint, you will see the assignment due. So I'm gonna put all the slides here. And if you cannot wait, again, let me know, probably throw them on WhatsApp and then put them officially on Blackboard in the evening. This is the recorded session that is still recording now. And you will click submit here. If you click on this one, there's somewhere where you can upload. And please upload one file PDF. Whatever you do, pictures, drawings, everything you want to put, click submit here and do it one file PDF. You can write something about it. If you want me to know something, browse your local files to submit. Okay, so back to your questions. Should we submit them? When will you upload them? In which form? Do we submit by email? Please do not submit anything by email. So let it be all on Blackboard because I can keep it there. All right. If you have any question, please email me, send me a text on WhatsApp. Let me know and let's meet anytime you want. Okay? All right.